Welcome to my channel. So today's topic has to do with fire safety, and that does not mean to make fire safe. What it means is to reduce the potential for fire on a property. Now this is based on my opinion and from what I've learned over the years living in California, which is a fire-prone area. This does not apply to all climates. It does not apply to all situations. From my point of view and my opinion base, and from what I've seen historically, we as humans can do a lot to reduce or mitigate fire potential on a property. We need to know which way the wind is coming from predominantly. We need to know where the slope of the land is. We need to know where the low points are for the forests and the shrubbery. We need to know where the grassland is, or the south-facing slope is, because south-facing is typically grassland in California. We need to know what the vegetation is and how often it's annual and how often it's perennial. And then from those points of view, we can start determining how to adjust the vegetation and adjust the potential for water to mitigate any future fires. And this is important because when people build in a standardized model, which is what happens in California, they build to what was offered by the city and or the state or the county as safe for their generalized area. What they typically don't get a lot of information on is the surrounding landscape and how to deal with it. So some of the points that I've heard over the years are to keep vegetation low to the ground. That includes all your grasses and annuals. To bring the tree canopy up above 9 feet. Some counties require, higher tolerances than that. But the crown of the crown of the tree should have no limbs that are horizontal below 9 feet. For most trees, I don't say all trees because there's some trees that will not tolerate that. There's certain pines and things and conifers that cannot have the loss of a vertical stack of branches. They'll die, and then they become fireweeds, which they already are. Then there's fire-tolerant plants and plants that resist fire, and those are two totally different aspects. A fire-tolerant plant is like, or similar to redwoods or oak trees, where they might survive a fire. They might lose all their leaves, they might lose a few branches, but they spring back in the spring when they get water. Redwoods do that, oak trees do that. There's a lot of trees that can survive a fire. Even though they look like they're dead, they're not dead on the inside. That's fire tolerant. Fire resistive is like agapanthus, which is a gel-based plant. And the fire hits it, and the plant resists the fire, and it takes the fire huge amount of calorie load to actually get that plant to dry out, and then turn it into a burnable substance, and then to catch it on fire. So the calorie count, or the fuel load that has to burn before the agapanthus can burn, is higher than grass, which doesn't take that much to catch on fire. So the calorie uptake of the energy burn for the fire that's coming through would be resisted by plants that are like gel-based plants, similar to cactus, agapanthus, baby sunrose, the succulents, the things that have gel inside them, the ground covers. A lot of ground covers have gels, and those would be not. How am I using my terminology? They'd be fire resistant, not fire tolerant. So an oak tree and a redwood would be fire tolerant. This lowland shrubbery would be fire resistant. It would actually stall the fire or stop it altogether, depending on the density. Then there's things like swales, fire breaks, water catchment, and hard surfaces that don't burn. Anything that can break the travel of ground fire is beneficial to the larger landscape. So fire breaks are like swaths that don't have any vegetation in them. Swales are depressions in the ground that follow contour and are usually more lush or wet, and are very difficult to burn. Hard surface is very difficult to burn. That'd be roads and pathways. And that will stall a fire from making progress forward, even in wind, because it's going to use all its fuel before it can jump the road, hopefully. And that's the whole point of the resistance factor for that fire. That does not mean that it's going to work in every scenario, in every case. These are the concepts of how to work with your landscape to reduce the potential for fire on a landscape. If you know the winds, the directional winds, fire travels at the speed of the wind with embers, and it can be pushed by the wind at the ground level. As it's being pushed, these factors can resist it. The fire breaks, the agapanthus, the willow trees, the things that would resist fire's travel at the ground level reduces the fire load uphill or downwind of the fire. Now, if we have a tall canopy can throw embers a longer distance than a short canopy can throw embers of distance. So if we have a shorter canopy, we reduce the tree-to-tree catchment of fire and the distance of travel. If we have a taller canopy and we can't get rid of it because it's native or something, then what we can do is we can bring up trees to mid-level and break the height of the trees between each other, and that way they're not contacting each other, not touching like this, but there's a break and there's a tree down here and there's a tree here. So the canopy is basically roughly solid, but there's a fire break between the tree heights. Obviously, if we have dams and rivers and water and catchment and swales and ponds, all that water is a fire break. All that water can be utilized by the fire department to put out a fire that's that's upwind of it or downwind of upwind of it. And so they can use that water to spray down a hill and wet vegetation and do things of that nature. They can pick it up with a helicopter and move it somewhere else. It's very good to have water catchment on properties. The houses themselves, we can use intermissent paint, which is fire-resistant paint. We can use fire-resistant materials like stucco and concrete. Now, that does not mean that the fire's radiation won't go through those materials and catch things on fire inside. What it means is that those materials don't typically burn because they're made of non-combustible products. What needs to happen from that point is there has to be a gap or an insulation layer from those products to the interior wall to stop the transmission of heat and thermal radiation from the wall through the wall into the room. Because the resistance of concrete is almost zero. So when it gets hot on this side, it gets hot on this side. It's not perfectly zero, but it's not very high. For instance, the resistance of standard insulation, pink insulation, usually has an R value of 6 or above. And what that means is the R is resistance, and the number is the number of hours it takes to transfer 1 calorie of heat transfer for 1 degree from one side of the item to the other. So however many calories it takes to heat up 1 degree of air over here and then transfer it through this to heat up the air over here, the distance between those is the resistance factor, and the number is in hours. So if it's R3, it'd take 3 hours to get this hot to transfer to the other side. If it takes 6 hours to get this hot, then it takes 6 hours to get to this side. It takes 30 hours, or it takes whatever. This gets hot and it takes 30 hours to get this hot. So the R value is depending on the transfer of heat and radiation. That works because air is a terrible transmitter of heat, whereas solid bodies are a great transmitter of heat. The denser the material, the faster the heat transfers. It's fairly simple. So when you're working out your designs for your house, you might want to consider having gaps and airspace to stop heat transfer from fires outside and from heat loss from inside to outside, or vice versa, cool loss, cool entrance and cool loss, depending on the season. It's very important to factor those things in. Houses should have a basement in areas that can have basements. Obviously, you can't have a basement in a swamp without a lot of effort. And basements inside of sand dunes are difficult. So, and basements in pure granite are difficult. So those are things that have to be factored into the equation as a person's building their house and determining the structure of their subsoil or their hardpan. As those things get figured out, the house itself can protect itself by using its municipal water or its cistern. Municipal water comes from the city or the county, and it gets pumped in. And then inside the house, you can have emitters. In the case of a room catches on fire, then an emitter will pop and it'll drench that room where the fire is. On the outside of the house, on the roof of the house, you can put emitters on top of the roof, and you can have those linked up to a cistern outside, and the water can be pumped back to the emitters. And then as it falls back on the roof and goes back into the gutters lead back to the cistern and it recharges itself. So it helps give the firemen a chance of getting to your house and solving the fire before your house burns to the ground. Another one is that gardeners will know this. You take a fire hose, or you take a regular hose, you put a sprinkler on the end, you run it out as far as it can reach, and you surround the house with fire hoses like that. You turn on all your spigots and you walk away. And what that does is it puts water on everything until the fire department takes over the main line and shuts that down. By the time they've shut that down, they're trying to protect the houses, and they're going to protect the houses that try to protect themselves, and the one that surrounded itself with water and sprinklers is more likely to be protected than the one that's got vegetation built up against the house. Now, speaking of vegetation built up against the house, this is a controversial subject, so hold on to your hats. Every fireman that I've ever talked to, or firewoman that I've ever talked to, has said, keep flammable materials, grasses, shrubs, bushes, and trees, including tree limbs, at minimum 3 feet away from the house. That's to stop direct fire transfer from the object to the object. Now, I would prefer a greater distance of like 6 feet, but I'll take 3 feet as a minimum because that's what I'm told by my people in the fire department in my area, in my localized area. And they also say that the material on the ground should not be any taller than 3 inches, which is about 1 fist. My fist is about 3.5 inches height-wise. So if I put my fist on the ground and anything's above my fist, I can very easily bring it down. And then I figure out a tool that is on a stick or something that has 3 or 3.5 inches and put it on the ground. And anything above that line gets cut with a mower. You can easily set your landscaping equipment. your mowers and your weed whackers to 3 inches. Weed whackers are slightly harder because you're guiding them, but they do have them where they can be on rollers and stuff. Your lawnmower can be set for blade height, and you can go 3 inches and just call it a day and never change that height. And you're at minimum what the fire department in my county wants. Flammable materials, specific trees like pine trees and other flammable trees that burn really fast and easily should be minimized to the number of those types of trees around a house. The Monterey pine is a protected species in Monterey County. I understand that, but it is a fireweed. It grows 60 feet tall, has a 50 to 60 year lifespan, and then it dies, and then it becomes a stick that falls over, and it crushes cars and takes out houses all the time. So in my opinion, if you have the available income and you have the available resources, taking down 60-foot pine trees around your house is probably advisable if you can get the city, the county to allow you to chop those trees down. It's just a problem in Monterey County. Replacing those trees is optimal. Replacing them with fire-resistant trees is optimal. Replacing them with fruit trees is like a double win. Fruit trees have a hard tendency to burn because they're usually very wet and they have a lot of good vegetation on them. Or in the wintertime, they're dormant typically, not all of them, but many of them. And they lose all their leaves and then they're just sticks. And it's very hard to burn just sticks. So you got to have something to catch on fire. So fruit trees can be beneficial next to a house versus pine trees. So those are the thoughts I have today. And if you have thoughts on it, leave them in the comments below. If you have interest in this kind of information, you can thumbs up and like this kind of material. You can even subscribe to the channel and ask questions, and I'll do my best to give you answers on subjects that I either know about or I'm willing to research to give you more information. So there you go. There you have it. Have a great day. Be out there. Be fire safe. Have a good time with your properties. Don't let this panic you. Just be reasonable about fire safety.